The moon. For 4.5 billion years, it has been our silent companion in the darkness of the cosmos. Yet movies and sci-fi have always shown us the exact same apocalyptic trope, a gigantic sphere slowly falling from the sky until it smashes into Earth like a colossal billiard ball. But the real physics of our universe are far more fascinating and terrifying. If the moon were to suddenly change course and start falling toward Earth, the truth is, it would never actually slam into the ground the way we think it would. Stick around until the end, because what actually happens is beyond anything you can imagine. It would all begin with a catastrophic event far beyond our human scale. For the moon to fall toward Earth, it would first need to lose its current orbital speed of 1 kilometer per second. That can't happen by magic. It could be triggered by a rogue star passing too close, or a massive asteroid impact hitting the moon in the opposite direction of its orbit. In the first few days of the disaster, as the moon slowed down and entered its death spiral, the change would seem almost imperceptible to the human eye. However, as the distance halved to about 200,000 kilometers, the laws of physics would begin to unfold in a horrifying way. On Earth, the first sign wouldn't come from the sky, but from the water. Tidal forces critically depend on distance. At half its usual distance, the moon's gravitational pull on Earth's oceans would jump 8-fold. This would trigger truly monstrous tides. We aren't talking about big waves here. We are talking about massive walls of water over 100 meters high, sweeping across continental coastlines. It would unleash the most devastating tsunamis humanity has ever seen. Entire coastal cities like New York, Tokyo, London, and Buenos Aires would be submerged under relentless waves twice a day. Meanwhile, on the moon, things would start changing too. Even though the lunar surface seems dead and static, Earth's escalating gravitational pull would begin to strain its internal structure. The moon's core, moderately warm and partially fluid, would experience violent internal friction. Primary cracks and fault lines would tear through the lunar crust, reigniting ancient moonquakes at intensities never recorded before. As the weeks pass and the moon crosses the 100,000 kilometer mark, the geological toll on both worlds turns catastrophic. On Earth, gravity isn't just pulling on water, it's pulling on the crust itself. The solid ground would bulge upward by meters as the moon passes overhead, triggering relentless global earthquakes above magnitude 9.0. Extinct volcanoes across the globe would wake up all at once, spewing ash and magma into the atmosphere, blocking out the sun and plunging the planet into a toxic gloom. On the lunar surface, the landscape would transform radically. Because Earth's gravity pulls harder on the near side of the moon than on the far side, the moon would lose its spherical shape. It would stretch slowly toward Earth, morphing into a gigantic almond made of rock. The extreme internal pressure would rupture its outer crust, causing deep layers of basalt and magma trapped for billions of years to spill onto the surface in rivers of fire visible from Earth. That brings us to the decisive moment, the turning point where real physics shatters Hollywood's illusion. This point is known as the Roche Limit. For the Earth-Moon system, the Roche Limit lies roughly 18,470 kilometers above our planet. So, what does this limit actually mean? It is the precise mathematical distance where Earth's gravitational pull overcomes the moon's own gravity, holding it together. Beyond this point, Earth's gravity is so intense that it disintegrates the satellite structure. When the leading edge of the moon crosses this invisible threshold, the catastrophe reaches its climax. Earth's gravity will yank on the front side of the moon with such violence compared to its backside that the cohesion of the lunar rock itself will collapse. The moon won't smash into Earth as a solid object. The moon will rip itself apart in space. Within hours, 3.8 billion cubic kilometers of rock, basalt, and dust will be shredded to pieces. Millions of trillions of tons of lunar debris will scatter along Earth's orbit. From the surface, if anyone were left to see it, the sky would be terrifyingly majestic. The moon would vanish, replaced by a glowing ring of debris, a dense, brilliant ring system encircling Earth's equator. much like Saturn's, but forged from rock and magma. However, this ring phase wouldn't last long. Lunar fragments, ranging from tiny grains of sand to city-sized boulders, would collide violently within the ring. This friction would slow them down, sending millions of tons of debris plummeting into Earth's atmosphere. What follows isn't a single meteor impact, but an unrelenting massive shower of fire and rock across the entire planet, lasting for days or weeks. As billions of tons of rock pierce the atmosphere at speeds over 40,000 kilometers per hour, aerodynamic friction will generate unimaginable heat. The kinetic energy of the entire shattered moon will convert into thermal energy upon contact with the air. Earth's atmosphere will literally turn into an oven. Air temperatures will skyrocket to hundreds, and then over 1,000 degrees Celsius in a matter of hours. The remaining oceans will boil violently into thick plumes of vapor. All vegetation, forests, and human structures on the surface will catch fire and incinerate almost instantaneously from the radiant heat in the sky. Could anyone survive such an event? The scientific answer is no. On the surface, complex life would be completely eradicated. Earth's crust would melt under the continuous bombardment and extreme heat, turning our planet back into a global ocean of magma, much like it was during its formation 4.5 billion years ago. What about underground shelters? Not an option either. Extreme heat would penetrate hundreds of meters into the ground, and relentless tectonic churning would collapse any subterranean structure. Furthermore, astronauts aboard the International Space Station would be wiped out in the early stages by hypervelocity debris generated during the Roche Limit breakup. This experiment proves that a massive object doesn't need to physically touch a planet to completely destroy it. Gravity is a double-edged sword. The invisible pull that keeps us orbiting in peace is the exact same force that could wipe us off the cosmic map. Thanks for watching until the end. If you enjoyed this video, don't forget to subscribe, leave a like, and comment on what catastrophic physics experiments you'd like to see next.